Welcome to a lesson with Dr. Powell. Let's take a look at how we can express derivatives as matrices and how we can use that to determine if we have a minimum or a maximum of a function, especially a function that has multiple variables as input. So we're going to think about derivatives as being linear maps or linear transformations, actually, from a vector space of runs into a vector space of rises. So going from runs to rise. So a run is going to be like a vector and the rise is going to be like a vector. And so it's going to be a linear transformation. That's now for single variable input functions, and one output variable. This is simply a 1-by-1 matrix, so it's a simple linear transformation from R to R, say, and like for instance, taking derivative of x squared. We think of it as 2x, but let's think of this as a 1-by-1 matrix. This is a linear transformation that takes us from run to rise. So we input, so in the column interpretation, we input run and then we output rise. So this is a matrix. For instance, what if we look at this derivative at a particular point, x equals 3? So we have to, so it's only going to be a linear transformation at a specific input place. So like x equals 3, for instance, here we plug in x equals 3 into that, and we get 6 as our linear transformation. So what does that mean? So if we input a run, we should output a rise. So let's suppose that we input 0.1 as our run. So if we have coming in 0.1, what is our rise? Our rise would then be, well, just 6 times 0.1 would be 0.6. So we would rise by 0.6. So that is if our run being 0.1 means that our inputs changed from 3 to 3.1 since we've gone on a run of 0.1 past x equals 3. And that means then our rise will have gone, well, at 3, the function is 9. And so this is, of course, an approximation. This is a linear approximation. So we're assuming that the function's behaving like a straight line, like a linear transformation shifted from a point. That's really what a derivative is. It's just pretending that a function is the same thing as a shifted linear transformation. Okay, so the rise we said would be 0.6. So that means will be approximately 9.6 using this approximation, this linear approximation right here. And that's what the derivative means. It's simply, okay, we input the run of 0.1, we output the rise of 0.6, and we know kind of how we can go with that. In fact, if we look at an approximation for f of x generally, so if we're thinking a run past 3, then we have the derivative at 3. So we plug in this input, this is the run, into this, and then we get out the output. The multiplication is the rise. The rise past 9, which is f of 3. So you can actually write down, this is actually the equation right here of the tangent line to the function f. So this is a shift of a linear transformation. That's one way we could think about derivatives. So in the videos that follow, we're going to be taking this idea and using it with functions that have more input than just one. Thanks for watching.